next is the position of tetrahedral and octahedral void in a FCC unit cell. FCC unit cell, that is called as a face-centered cubic cell. The face-centered cubic cell where the particles are present on the corner as well as at the center of each faces is called as face-centered cubic cell. Now, face-centered cubic cell or the unit cell is obtained when the particles are when we have the ABC type packing. If there is ABC type packing, then only the face centered cubic cell is obtained. And when I'm talking about the ABC type packing, then in the ABC type packing we are having two types of void, that is called as a tetrahedral and octahedral void. So while drawing the FCC unit cell where those tetrahedral void and octahedral void comes, we have to learn about this. So position of tetrahedral void and octahedral void in a FCC unit cell. Okay. Now, let's see the positions. In an animation, we are having a face-centered cube. We have a cubic cell. A cubic cell. Let I'm dividing this cubic cell into a two part, vertically, then horizontally, and then from in between. So ultimately, I draw three planes in the cubic cell, and due to these three planes, I can say that whole cubic cell has been divided into 8 small cubes. So now we are talking about the tetrahedral voids. Each small cubes, we have 8 small cubes, and just consider the center of these 8 small cubes. At the center of each small cube, we will have a tetrahedral void. That means a tetrahedral void is present at the center of each small cube. So there are total 8 cubes. So I can say that in a FCC unit cell, there will be a total 8 tetrahedral voids present in a unit cell. Now these 8 tetrahedral voids, now simply how to remember where they are present in a cubic cell? Then simply I will say when we join the diagonals of these cubes, after drawing these all the things, when we start drawing the diagonals of a cube, we come to know that at each diagonal of a cube we get the 2 tetrahedral void. There are total 4 diagonals can be drawn in a cube. So and on each cube there is a on each diagonal there is a 2 tetrahedral void. That means again I can say 4 diagonal into 2 tetrahedral void. That means again I can say that there is a 8 tetrahedral voids are present. Okay. Now I know the relation that if there is n number of sphere, then the number of tetrahedral void is 2n. We have this relation that if n number of sphere always have a 2n number of tetrahedral voids. Now let's see the same relation here. In this face-centered cubic cell, which we just in the face-centered cubic cell, as I said, if it is if the cell is of FCC, then how many particles will be there in FCC, or how many atoms? So I can say the number of atoms or particle which are spherical in shape, FCC unit cell. In FCC, the particles are present on the corner. There are total 8 corner, as well as it is present at each face center, and there are total 6 face center. The particle present on corner, we have 1/8 contribution. 8 corners are there, so 1/8 into 8. Face center, it is half into each faces have the half of particles. Face into 6 faces. So I can say here the 1 plus 3, that is the 4 particles are there. Now how many? So at least I can say that there is a 4 atoms, that is a 4 spheres. So how many tetrahedrals will be there? As I said, if there is a n number of sphere, then number of tetrahedral void is how much? 2n. So it is expected that the number of tetrahedral void should be equal to 8. Now let's see whether it is 8 or not. Now in a figure I can say that the tetrahedral voids are present at the center of the unit cell, at the center of each cubic cell. Now when it is present at the center of each small cube cell, the question arises, suppose the tetrahedral void which is present in every cube, a small cube, there are total 8 cubes, whether they are property of the same unit cell or it is shared by the other unit cell also, then I can say that each tetrahedral void, if I am keeping a small spheres in these tetrahedral void, then they are going to present in a same unit cell. So I can say whatever the particles will be present in a tetrahedral void, or whatever the tetrahedral void we are having, they are going to be present in a same unit cell. That means it will not be shared by the other unit cell. So here, since all the tetrahedral voids will present in a same unit cell, so no other cells are contributing it. So I can say that number of tetrahedral void is equal to 8. All 8 tetrahedral void is present. So full 8 voids are there. So 4 atoms, that is a 4 sphere, and the tetrahedral void is 8. So where the tetrahedral voids are present, simply I will say the tetrahedral voids are present at two tetrahedral void are present at each body diagonal. And there are total how many body diagonal? I can say there are total 4 body diagonal. That means 8 tetrahedral voids will be there. Okay, this is about the tetrahedral void. Now let's talk about the octahedral void, where the octahedral voids are present. Now the octahedral voids are present at the octahedral voids, they are present in the 2 position. They are present at the edge center, and the octahedral voids are present at the body center, exactly at the center of the unit cell. So there is a 2 position for the octahedral void. If we have a FCC unit cell, then octahedral voids are present at 2 different positions, that is the edge center and the body center. Now in a diagram again you can see the position of the octahedral void. The octahedral void which is represented by the yellow color spheres, and the tetrahedral void which is represented by the red color spheres. You can see in a diagram that yellow color spheres, that is which is representing the octahedral void, they are present at the edge center. There are total 12 edges and they are present at every edge, as well as there is a one red tetrahedral octahedral void which is present at the center of the unit cell. So in a FCC unit cell, the octahedral void is present on an edge center as well as it is present at a body center. Now let's see how many octahedral voids are there in a FCC unit cell. The particle present at one edge. The particle, suppose there is a one particle present at a one edge. How much part of that particle will be, means what will be the contribution of that particle in a single unit cell? So I can say that the particle present at a one edge will be shared by the 4 different unit cell. So the particle present at an edge is shared by 4 different unit cells. So in a unit cell, its contribution is going to be 1/4. And there are total how many edges? 12. So 1/4, that is 3. Body center. The particle present, the octahedral void which is present exactly at the center of the body will not be shared by the other unit cell. So the total contribution of this octahedral void which is present at a body center is 1. So I can say that how many octahedral void is overall there? Then I can say that 3 plus 1, that is 4 octahedral voids, 4 octahedral void. And we have the relation that if there is a n number of sphere, the number of octahedral void is also equal to n. So in FCC there is a 4 atom, that is a 4 sphere. So octahedral void is also equal to 4. So from this we got this relation that how many spheres and how many octahedral voids or how many tetrahedral voids will be there. So this is about the position of tetrahedral and octahedral void, where it is present. Simply I will say they are present at the center of the each body, they are present at the body diagonal. Each body diagonal have the 2 tetrahedral void, while the octahedral void, they are present at the body center and the edge center. From edges we get the 3 octahedral void, and from the body we get the 1, that is 4. And number of tetrahedral void, whatever the tetrahedral voids are present in a unit cell, they are completely a property of the same unit cell, means they are not shared by the other. So number of tetrahedral void is 8.